Today we are going to deal with the topic ATM, Asynchronous Transfer Mode. ATM is a high-speed transmission protocol which data blocks are broken into small cells that are transmitted individually and possibly via different router in a manner similar to packet switching. ATM protocol architecture or ATM protocol reference model. Here in the next slide, the figure describes the relationship between the planes and layers of ATM protocol architecture. Okay. Here, the main function of ATM is multiplexing various logical connections over single physical interface. The purpose of ATM is to send the complete information in small fixed size packets called cells. The maximum size of cells is 53 bytes, out of which 5 bytes are used for header and 48 bytes are for payload. ATM is a protocol which has minimum error and flow control mechanism. Okay, and coming to this diagram, here this diagram we have different layers: physical layer, ATM adaptation layer, and here we have planes, control plane, user plane and 3 planes, that is management plane. Okay, and apart from this we have higher layers also. This ATM is responsible for controlling the transmission and receipt of bits as well as maintaining the boundaries of ATM cell. This one, physical layer. Okay, and ATM protocol reference model makes reference to 3 separate planes. First one, user plane, second one, control plane, and third one, management plane. Okay. And user plane, here what is user plane? User plane provides for user information transfer along with associated control, that is flow control and error control. And coming to control plane performs call control and connection control functions. Management plane includes the management functions for whole systems, whereas layered management incorporates management function of the specific layer. And coming to physical layer. Okay. Here, physical layer. This layer corresponds to physical layer of OSI model. The physical layer is responsible for managing the medium dependent transmission. It carries the ATM cells by converting them into bit streams. As we have studied earlier in OSI model, what is a physical layer? Here all bits, the data is converted in the form of bits. Okay. So at this layer, the cells are converted into bit streams and transmitted over the physical medium. It is responsible, this physical layer is responsible for controlling the transmission and receipt of bits as well as maintaining the boundaries of the ATM cell. Originally, ATM was designed to use synchronous optical network. Here the synchronous optical network is nothing but SONET as a physical carrier. Okay, and this layer has 2 sublayers. One is PMD sublayer, physical medium dependent sublayer, and TC, transmission convergence sublayer. Physical layer involves the specification of a transmission medium and a signal encoding scheme. The data rates both higher and lower are possible. The data rates specified at the physical layer includes 155.52 Mbps and 622.08 Mbps. And apart from this, the physical layer has 4 functions. First one, to convert bits into cells. Second one, tracking of cell boundaries. Third one, transmission and reception of bits on the physical medium. And fourth function is packaging of cell into frames. Next comes the here. See, if you observe, after physical layer, next comes the ATM layer. Okay. What is ATM layer? The ATM layer provides routing information to the data cells. This layer is comparable to data link layer of OSI model. Means the ATM layer is same as that of data link layer of the OSI model. ATM incorporates end-to-end protocols and ATM provides routing information to data cells. It interfaces AAL and physical layer because as it is in between the ATM adaptation layer and physical layer, so it incorporates, ATM layer incorporates end-to-end protocols and it interfaces AAL and physical layer. Okay. And next, it accepts 48 byte segments from the upper layer, adds a 5 byte header to each segment and converts into 53 byte cells. This layer is responsible for routing of each cell, traffic management, multiplexing and switching. And next comes ATM adaptation layer, which is nothing but AAL. AAL provides the flexibility of a single communication process to carry multiple types of traffic such as data, voice, video and multimedia. This layer corresponds to the network layer. AAL layer corresponds to the network layer. Okay, ATM network and use its service. Here, it provides facilities to the existing packet switched networks to connect it to ATM network and use its services. It accepts the data and converts them into fixed size segments. The transmission can be fixed or variable data rate. ATM adaptation layer divides the information into small segments that are capable of being inserted into cells for transport between two end nodes. Okay, here this AL is divided into two major parts, upper part of the ATM adaptation layer and lower part, two parts. Here upper part is nothing but, see, if you see that here it is divided into two layers, upper part and lower part. The upper part of ATM adaptation layer is called convergence sublayer. Its job is to provide the interface to the application. The lower part of AAL is called segmentation and reassembly sublayer. It can add headers and trailers to the data units given to it by the convergence sublayer, that is nothing but the upper part, to form cell payloads. There are several AAL protocols defined, classified based on the parameters. Okay. Here we have ATM endpoints. It contains ATM network interface adapter and examples are nothing but workstations, routers, codecs, LAN, switches, etc. And it has the parameters like timing relationship, bit rate and connection mode. And ATM switch, it transmits cells through the ATM networks. It accepts the incoming cells from ATM endpoints, UNI or another switch NNI, updates cell header and reads transmit cell towards destination. And finally, the goals of ATM adaptation layer or simply AAL are providing services to the application layer, making fixed sized cell at the source, segmentation and reassembling at destination, timing and flow control, handling transmission error, and last but not least, handling lost and misinserted cell. So the AAL handles all the transmission errors and lost and misinserted cells also. Okay. Thank you.